Hello everyone. Today we are going to discuss Remedial lecture number 8 for synchronous machine. In this lecture we are going to discuss the ASA modified MMF method. ASA or modified MMF method consider the saturation effect for calculation of regulation. In the MMF method, the total MMF computed is based on the assumption of unsaturated magnetic circuit, which is unrealistic. In order to account for the partial saturation of the magnetic circuit, it must be increased by certain amount FF2, which can be computed from OCC, SCC and the air gap lines as explained in the figure 1.201 and second. We can see here that field current 1 and field current 2 corresponds to give the resultant MMF F2, which is extended further to give the direction of resultant MMF F. Now this is the second diagram talking about, it is showing the characteristic for OCC, air gap line and SCC. So in this curve we can see the resultant MMF direction is extended by F2 and F, and the corresponding points are shown giving voltage E, and both the lines on one is on OCC characteristic, the other one is on air gap line. So let us see how we will find out this. If IF1 is the field current required to induce the rated voltage on open circuit, and draw IF2, which length equal to the field current required to circulate the rated current during the short circuit at an angle 90 plus phi. So we again see here that F1 current is shown here, which is required for the OCC characteristic to find out the rated voltage. This thing is corresponding to the F1 is corresponds to the voltage V, and again by extending the field current by 90 plus phi, an additional voltage is added to the value of the field MMF. So this is the change required. Draw IF2 with length equal to the field current required to circulate the current during the short circuit condition at an angle 90 plus phi from IF1. The resultant of IF1 and IF2 gives IF as shown OF2 in this figure. Extend OF2 up to F so that F2F accounts for additional field current required for accounting the effect of partial saturation of the magnetic circuit. So by extending the values OF, FOF, OF2, extend OF2, extending OF2 to value F, extending this thing to value F, we can consider the part of unsaturated region, which is actually saturation, magnetic saturation, considering the magnetic saturation. So now the values becomes F2F. This is the additional current required for the accounting of partial saturation of magnetic circuit. F2F is found for E voltage, refer to phasor diagram of MMF method. This voltage corresponds to this additional, adding this thing we get this corresponds to F2F, and drawing this thing laterally here and touching this point to the OCC characteristic, we can find out E0, which is the actual terminal generated voltage and which is supplied to the alternator. So this is the actual generated voltage E0. We can find out using the OCC characteristic, and it corresponds to considering the partial saturation of magnetic circuit also. So now we can find out the regulation, and this regulation is more realistic because it is considering the magnetic saturation also. That's why this gives more realistic results and which match to the actual value of the voltage regulation. So this is all about the ASA method of voltage regulation.